we have one of the most challenging assignments that has ever been given to modern man. Expansion of human knowledge about space.
Greetings from the International Space Station.
We have been busily working in the Urban Engine office.
We are going to be to space travel what the Silicon Valley has been to electronics.
I'm here in Huntsville, home of the main stage for Space Apps 2018.
Which means this is the premier location for globally for this whole thing, right?
Yeah. So there may be some questions that you have.
I'm NASA astronaut Drew Feustel, orbiting aboard this magnificent laboratory 250 miles above the Earth. Welcome to the 2018 International Space Apps Challenge.
You don't have to be an expert at space or software.
This weekend, please connect with participants all around the globe as you create solutions to the world's greatest challenges.
It's not just about the science, it's not just about the engineering technology, it's also about the art, the presentation.
Space Apps Huntsville is part of an international event that happens in cities around the world at the very same time every year.
And this event, the Urban Engine sponsored NASA Space Apps Challenge, is just one more step on our path to that vision.
Range apps to blockchain technology.
That's what I'm looking forward to.
Last year in 2017, there were 187 host cities that participated in the International Space Apps Challenge and 25,000 participants. At one point, the International NASA Space Apps Challenge was the world's largest hackathon. And for the second year, Urban Engine is facilitating this event in Huntsville, Alabama. We will have it at the U.S. Space and Rocket Center in their educational training facility. We're going to start the program in Huntsville with an expo that will be on Friday, and that begins at 8 a.m. Proud to showcase all of our creative thinkers, makers, doers, innovators. We're really looking forward to seeing you out there, showcasing what we're made of right here in Huntsville, Alabama. Thank you to all of our sponsors, all of our exhibitors that will be there. Thank you for making this possible for us. It is a privilege, and I am looking forward to seeing you next Friday, Saturday, and Sunday at the U.S. Space and Rocket Center.
Okay, hi everybody. Welcome back to the Space Apps Challenge, our special closeout for Friday afternoon. We are going to be fabulous passion panel to talk all things space exploration. And I'm going to introduce our moderator for the panel, Emily Trapani. She is a regional manager with Google Fiber. We are so excited to have her leading the panel. And Emily, without further ado, I'll hand it over to you to introduce the rest of our guests.
Thank you. Mic'd up, I'm good, thank you. So today we're going to talk about space exploration and what's to come in the future and interview some very smart people who are working on technology and science here right in Huntsville. First we'll start just by introducing everyone. So first we have Tia Ferguson. Can you raise your hand? Tia is the Director of Space Systems, the Space Systems Department in the Engineering Directorate at Marshall Space Flight Center. We have Tiffany Russell Lockett. She is currently the Project Systems Engineer for the Near-Earth Asteroid Scout Flight mission. We have Dr. Bill Cooke, who is the lead of NASA's Meteoroid Environment Office. And we have Dr. Jessica Gaskin, who's currently working on NASA's MSFC astronomy group and is the NASA-appointed study scientist for the Lynx Large Mission Concept Study. So let's start first, if each of you could just give us an idea of your current work and what you're working on. Bill, do you want to go first?
Sure. So basically, I'm NASA's space rock guy. So my job at NASA is to predict meteor showers, forecast their activity so that we can protect spacecraft and make sure the astronauts on space station don't go outside when they should. And I also come up with models that help designers place shields to protect sensitive parts of their spacecraft from meteoroids out in space. And when I'm not doing that, when people across the country see a bright light in the night sky, I turn into Chicken Little and tell them whether it was a meteor or a piece of re-entering space and stuff like that. So that's what I do in a nutshell.
Tiffany, what are you working on?
So right now I'm working on what's called a CubeSat. It's a 6U, it's about the size of a shoebox, spacecraft that will be launched on the Space Launch System in the next few years. Payload, we are designed to fit in a really small volume but do really big science. And as a systems engineer, I look at the project as a whole. I look at the actual spacecraft itself, the requirements that are needed to build that, the science that we need to do, and also make sure that we're meeting the overall mission objectives and doing no harm to the launch vehicle that we're riding on.
You guys work together. Tia, do you want to explain what you're working on?
Yes, I'm the director of the Space Systems Department, and we are part of the Engineering Directorate at Marshall Space Flight Center. And I'm a manager, so I do more of the strategy and technical decisions that kind of govern a whole bunch of different experiments and payloads. And Tiffany is working on one of them, which is working in our space technology area, doing technologies to go do our exploration missions. Another area is the software and avionics for the SLS rocket. Y'all just saw a presentation from Trey from SLS, the Space Launch System. And we also work on science experiments like the high energy X-ray polarimeter experiment that is going to be studying black holes, and in the area where Jessica is working on her Lynx project. And so we do a whole bunch of engineering across the center and the agency. And I wasn't always a manager. I do have a degree in mechanical engineering from Tulane University and electrical engineering from University of Alabama in Huntsville. Up designing science experiments and gotten to do a whole bunch of things in my career around those areas.
Dr. Gaskin also grew up, right? You've always been at NASA. Do you want to explain what you're working on?
Sure. So I work in the Science Mission Directorate. We do basically, that's where we sit at Marshall. And some of the projects, I'm an experimentalist, some of the projects that I work on now are Lynx, as Tia mentioned, which is a very large flagship mission concept that may fly in the 2030s. So we have these really large observatories like Hubble and the Chandra Observatory. So Lynx would follow after James Webb and W First Fly. That's one of the concepts that we're studying, and I'm the study scientist for that mission. So I help ensure that the community and the science that the community wants to have done translates into requirements and a concept that we can actually build, and cost and schedule and all those fun things. I also develop other instruments for astrophysics, for mainly for X-ray, different types of X-ray platforms, and I also do a little bit of planetary instrument development.
We will get into some of that. Before we do, I want to orient us around where we are in Huntsville and how we got started. And I think, Bill, you're a resident expert. Maybe you can give us the history of Huntsville and how Huntsville kind of got started in space.
I'm only the resident expert because I've been around a lot longer than most people. Huntsville was pivotal in the early parts of the space program, right? You had Von Braun and his rocket here, and they're responsible for the Redstone booster that put the first Americans in space. And you had the Apollo, the great Saturn V developed here in Huntsville, right? A lot of people don't realize that KSC used to be just a launch site associated with Marshall. So in the old days, Marshall people would go down to KSC, and that's when the first Mercury Redstones lifted off. And, you know, when I was growing up, I was born with the space age, so as things developed, it seemed like rockets were going up every other month. You know, at first there were the Mercury missions, and then there were the Gemini missions, and so we went from 1 astronaut to 2, and they were doing all these things up there and docking with things. And then finally we got to Apollo, and, you know, the excitement kept building, okay? And, you know, you had that wonderful moment when Apollo 8 launched on top of the first manned satellite and slingshotted around the moon and came back to the Earth around Christmas. And that was very exciting. And then it was followed up by Apollo 11, which was, of course, the first moon landing. And I was 10 years old. You know, I was about to turn 11, and I was glued in front of my television set with my family. And, you know, you saw and everybody, it's like the world stopped. You know, you would get these reports that everybody in the world was watching that. And you saw this ghostly white figure on very crappy TV. It wasn't HD at all, okay? This ghostly figure, could barely tell it was a person in a spacesuit to and step out on the surface of the moon. And it was like everybody was cheering. you know, and that was a pivotal moment. And if you were there watching it, you knew the human race would never be the same afterwards. We set foot on another world. So, you know, and Huntsville was a big role in that. You look at the Huntsville newspapers, there were celebrations in the street in Huntsville back then. You know, I was in Chattanooga. I'm surprised I didn't hear the celebrations all the way over there. And then shuttle came along after Apollo. And the first shuttle launched exactly 20 years after Yuri made the first manned flight into space. 2 decades. And shuttle changed everything again. Instead of this Saturn sending men to the moon, we had a truck, this fabulous truck that could put things like Hubble up there and build space stations in Earth orbit. And the shuttle kept us going, and because of it, we have Hubble up there. We have the space station up there. And now we got SLS, which is going to carry us beyond Earth orbit and put these wonderful habitats in orbit near the moon. So we're leaving that behind, and we're going to have SLS. So in my lifetime, I've seen a lot, and I'm hoping to hang in there long enough to see the first person touch down on Mars. It's going to be tough, but I'm hoping to hang in there long enough.
This is a good history lesson. I don't have to ask kind of my follow-up question, but you talk about this pivotal moment where you're 10, almost 11, right? Like watching us land on the moon for the first time. And I want to know from everyone, what do you think? I think my 5-year-old daughter is probably watching this. So what's her generation? What's the next generation's moment going to be in the future? We know where we are now in Huntsville. What's going to be that next, like, generation-defining science that'll happen in space? Do you want to answer? I've asked you this before. Do you
Sure. I think one of the biggest moments is going to be when we watch the SLS vehicle launch from Kennedy Space Center. And just to know, like Bill was saying, that it's going to carry us back to the moon and then to Mars and help us be able to man this lunar, is what we call, around the moon. And it's just going to be really exciting. But I think another pivotal point is, I'm hoping, and it's all a matter of opinion, that we're going to, in our lifetime, see that there is life somewhere else in the universe. And I know they found a lake deep in Mars, and we have Europa that has a saline lake underneath the ice surface. And, you know, part of the SLS is going to carry us to Europa in record time so that we can get there in a 2-year time frame and to be able to go and look for the signs of life. And I think that'll just be phenomenal.
He doesn't think there's life there. He thinks there's life somewhere else, right?
I'm a sparse lifer. What can I say?
What do you think is coming up next? What do you think is going to be that? Do you agree?
Well, I definitely, for the science side, all of the biology experiments that are going on, what Mars Curiosity rover is already doing, looking for water and what's in that water, and the follow-on Mars 2020 rover is going to do even more science, and we're going to do our Mars sample return mission in the early 2020s. And so, you know, we have moon rocks. You can go to the Smithsonian right there. But, you know, within the next 10 years, we could have Mars rocks that you can go and see in person and learn more about their composition. I think that would be pretty cool for the next generation.
And one of the payloads that we're working on now is the Mars Ascent vehicle, which is going to take some samples that are created from our Mars 2020 launch and shoot them up into space, and an ESA orbiter is going to capture those and bring those back to the Earth. So it's really exciting. That's probably going to be in the late 20s that'll happen.
20s and then 2030s.
2030s.
So what do you think is coming?
So I don't disagree that human exploration is a big part of what we do, but I think one thing that we have to remember is that NASA does a lot of things really, really well. Look at Hubble and Chandra, and the amount of information that we've learned about the universe in a couple of decades has been phenomenal. So finding even microbial life in the oceans of Europa, that would be really great. But seeing the very first black holes in the very first galaxies of the universe would also be incredibly phenomenal. And that's something that we have planned. Something we want to do is learn how the universe came to be, right? So I think what makes NASA great is not that they just have a human exploration program and just astrophysics or planetary or earth science or helio programs. They have all of it. And so hopefully it's that body of knowledge that we'll keep looking at rather than the one thing that is a pivotal point. So comprehensive observatories.
So this segues well into the biggest problem we're trying to solve right now. So any of this without the work that you're doing immediately. So I'm going to ask Tiffany, you first. What is the biggest problem that you're trying to solve today that will snowball into and enable you to do all of this great work?
So one of the major things that we're focusing in on is miniaturization of space and being able to take these larger missions that, say, could be the size of a school bus, and can you do that same amount of science in something that's order of magnitude smaller, a spacecraft that's the size of this coffee table, something that can fit in your pocket. You know, just look at the revolution of the cell phone. We've gone from brick phones in the early 80s. All have a cell phone in your pocket right now that you probably don't like talking to people and using it as an actual phone. You use it for everything else that is able to do, right? So if you take that same philosophy and apply that to space technology and space exploration. So one of the things that my mission is doing is these CubeSats that are traditionally used as test beds that are launched off a space station, launched in low Earth orbit. Can we push the boundaries and send them beyond? Can we go to an asteroid? Can we go to Mars and actually do really good science or help with the overall architecture, relay communications, send more data back so that that data is then available here on Earth so that we can process more for, of course, with it being smaller, for a cheaper price, which, you know, we're a government agency, so we're always looking for ways to save money and enable more people in the community to do science as well.
I asked Bill this question, and the answer was to forecast the meteors for the entire year next year, but he already did it, like the other day. So do you have a new big problem to solve?
Sure. We always have problems to solve,
Right.
right? So, since we got our meteor shower forecast for 2019 out, so we're turning back to making improvements to our model used to design spacecraft. And we're making some improvements that with the directionality and stuff to better help people put shields over the right part of the spacecraft, right? When you get up there, you've got to have shielding over sensitive components because a meteoroid, only a millimeter across, so imagine a millimeter, that has the kinetic energy of a bullet. So if one of those hits your spacecraft, it's like you shot it. So anything that's sensitive has to be protected. So we constantly tweak that model so our spacecraft are better protected and can survive, especially if they're going on long hauls like Jupiter and Saturn and other places, because they're going to be out there a long time.
How does the planning affect the work that you do? So testing systems before they go up, I think it does cause a lot of this science to cost more. It increases the cost the more testing that you do.
It absolutely does. So I think you're right in that we want things accessible to more people, and you can fly on even CubeSats. College students are flying, off-the-shelf components, and they're working really, really, really well, and they fly these really high-altitude science balloon payloads. But on a large observatory that costs billions of dollars, you want to do a lot more quality testing, quality assurance, and you want to make sure that those elements don't fail. So even if they are miniaturized, which would be great because you can fit a lot more into the same package, you have to spend more, unfortunately. But that's okay. We get this great reliability. Hubble was supposed to be a 15-year mission, and it's lasted for, 26, 28 years. Chandra was supposed to be a 5-year mission. It's lasted for 19 years, so next year's our 20th anniversary. And that's what we want. We want this investment for everyone. We want it to stay around, so we're not spending billions of dollars on something that might fail.
I do want to ask you about failure, and T, I want to ask you about failure too. So in Silicon Valley or in big tech, failure is a good thing, and there's billions of dollars invested into startups annually, and it's important to fail big and often and forward. Failure might not necessarily a great thing for NASA, or maybe it is. So my question for you is, how do you think NASA thinks about failure and risk aversion, and how does, the appetite for failure, kind of public's perception of that, impact the work that you're doing?
That's a great question. And I'll just start by saying that I haven't always thought that I would work at NASA. And when I was in college, that's when the Challenger accident happened. And I got really interested in watching what NASA was doing to recover and to get back into orbit. And since then, we've had the Columbia accident. And it's always a really scary and sad time where NASA takes a lot of time to look into accidents and what's really happened, and we want to understand that so that we don't make the same mistakes twice. And another consequence of that is that you end up adding more and more requirements so that you will reliability that we want. We want to be 100% reliable so that we know that humans will not die in the process of going into space. And it's a really risky business, sending astronauts into space. But you'll never get 100% reliability. So we do risk management, the minimum amount of risk, so that you can still achieve space flight. And it's a very difficult question. And it's one that actually our partners, SpaceX and some of the other companies, are able to take more risks, and they're able to change that equation because differently than NASA has in the past years. And so we're learning. It's a continual learning process. There's a lot of strategy in NASA now to try and figure out the right balance of risk. How much can we take? And knowing that you'll never get to 100%, we have to continue to try and challenge some of the requirements that we ourselves over all the years so that we can eventually get to a place where we'll be able to successfully travel and the amount of time that we want to take to get back to the moon and then on to Mars.
Dr. Gaskin, what do you think about failure and the public's perception of failure as it relates to what you're doing, where you're launching something that will be up there for 5 years or 30 years?
I think the challenges that NASA takes on are really hard challenges. We do hard things. And I think that if we're unwilling to accept that there will always be some level of failure, and accept that as a good thing, and obviously not when it involves human life, but on the science observatories that I work on, for example, knowing that what we're doing is hard, and it's not, and ever increasingly hard, we become more ambitious goals, which means our observatories get more complex and even harder to build. I think we have to understand what failure means, and that it's not always a bad thing, and be willing to accept some level of failure when we do things, build from it, learn from it, and move on to produce something that is so amazing and will last for a really long time. At the same time, there's, like Tia was saying, there's a balance. You have to have a certain level of quality and consistency. So it's finding that level. I do believe, though, that often, NASA does all these amazing things. We send these huge telescopes into space, and we land, landers and rovers on Mars. We put humans on the International Space Station all the time. And when one thing goes wrong, it's all over the place, right? Like instantly, this is what happened at NASA. And I think it's just a perception that we've put on ourselves these really high standards, and when one thing goes wrong, it looks like it's the first time anything's gone wrong. But it's just part of doing what we do. It's part of doing things. We're human, and humans make mistakes. We fail, but then we get up again and we do better.
Speaking of the private sector, commercialization, and a little bit of failure, when someone like Elon Musk puts a hype man in a Tesla on a rocket and ships it into space, right? There's just so much energy around it, and news and PR, and it gets everyone so excited. And so I'm going to ask you this, Tiffany. What happens to the work that you're doing, or NASA in general? How do you guys think about commercialization and when the private sector gets involved and does crazy things like that?
We think it's great. I was at work and we were in a conference room enjoying it, and we're just as excited as everyone else, because it's not just us that want to go into space. There's private individuals, there's institutions, there's this whole drive for space tourism, and we need all hands on deck to be able. And not only that, but a lot of the goals farther out into the future, especially landing people on Mars, that's not just going to be a U.S. thing. It's not just going to be the European thing. It's going to be everyone is going to be involved in some aspect of it. So really, we are investing through the commercial program, commercial crew. We're investing in companies like SpaceX and Orbital, and ensuring that the lessons that we've learned in developing our systems in the past, they're able to apply and maybe find some newer, leaner ways of getting there. And so that's where the partnership comes in hand. You're always going to get good progress when there's healthy tension, I believe. So I really enjoy, at least in the CubeSat land, that I can go online and look up Pumpkin and say, oh, I need a command and data handling system, and I can trade several different private companies, have different versions of it, but they're flying, and I could just pick and choose which before we had to custom make for that particular mission. So that's always I think that's a great thing.
Tia, can you talk about some of your work with NASA's partners and how you view the private sector kind of augmenting the projects that you're working on?
Yes, like Tiffany says, it's great to have the partners. It's going to take all of us to get there, and we at NASA see it as a great thing that we're going to have the new SpaceX and Boeing ULA that's soon going to be taking to the space station from U.S. soil, and that's really exciting to get back to. And then we have all sorts of small businesses like that Terry Taylor was talking about earlier, where one of the projects we're working on is ECLIS, Environmental Control and Life Support Systems. And we're successful in turning urine back into drinking water and turning the carbon dioxide, removing that from the air and replacing it with oxygen. And we've done a lot of this through small businesses, and it's through companies that create these technologies that some of them start. It's kind of like what we're doing for the space apps today, and create these businesses that end up flying in space and helping us solve some of the most difficult problems that we have and are going to see going to Mars. And so the partnerships are extremely important. It's going to take things like this where we've got more involvement from everybody who has great ideas, who can come to the table and help us solve some of the more interesting problems.
Dr. Gaskin, I'm going to ask you this one, because you tend to do a lot of work with mentoring and kids, and there's so many kids that are watching this. Beyond curiosity, what do you think is the most important skill that they can work on or work towards so that they can ultimately be doing this someday?
I think what you have in common here is that everyone is very hands-on. You have your job, and then you have your life, which is part of your job, which is always kind of building and touching and involving, and you're always involved in something pretty amazing. So what you can do as a high school student or a college student is not just go to your classes. You can go find those space hardware clubs and launch cubes. I mean, it's pretty amazing. We have the University of Alabama, Huntsville Space Hardware Club launches, payloads on large balloons, 60 million cubic foot balloon. They also launch CubeSats. So go to your local university if you're in high school, or in high school, you can use a small balloon up to 100,000 feet, 90,000 feet, and fly your own payload. Anyone can do this. And because you have all of these external vendors and their commercial parts everywhere that are very inexpensive and easy to use. So I would say get as much practical experience whenever you can. Be very proactive about it, and step outside of your comfort zone, and don't be afraid to fail.
Before we go to questions from the audience, I'm going to ask some conspiracy theory questions. I think Reddit has encouraged that this happens, so just bear with me. I'll ask you first, Bill. Is there alien life? Yes or no, right? Is there alien life?
Sure.
Where is it?
Well, probably not in the solar system.
Okay.
Somewhere in the galaxy. I don't think there are lots of them there, but they're out there.
Okay. Here's a good one. Why are the data streams from NASA, such as data from Mars, delayed? Why can't we get them instantly? Why is the data 6 weeks, 3 months, not instant? Are you hiding something?
Oh, no.
Who is this directed at?
Anybody. What do you think?
Well, I know Bill had answered this before.
Well, you know, look, so let's say an experiment and it's going to Jupiter, just for grins and giggles. And you're the guy or the gal who designed that experiment, right?
Yes.
Well, as part of your deal, there's a deal you make with NASA which says as that data comes down, you have exclusive rights to that data for a limited period of time and it goes in the public domain. It can be 6 months, it can be a year. So during that time, you're getting this data, and since you built this thing, you get first crack at the science from it. So it's not out there in the public. It's no conspiracy. It's just the fact, hey, I designed this thing. I want first shot before everybody else piles on. So that's one of the reasons why data coming down from spacecraft takes a while to filter out into the general public. Now, some things are out there instantly. Look at the live feed from Space Station, right? That's out there immediately. Okay, so it all depends, but there's no conspiracy theory. It's, you know, in the case of this, hey, we want first dibs, and, you know, for the other stuff, it's, you know, well, it comes down live, but there's no conspiracy.
Do you have anything to add?
Yeah, I mean, I agree. I think a lot of data does come down instantly, and you also have general observer programs for some of the large observatories. So if you anyone can propose, and if they win, they get the data. And then it gets archived a few months later, and anyone can have the data. So there are these archives and all of the tools to analyze the data online. So even now, any of you can go out there, grab some archived data, and analyze it.
I was going to add, as the project manager for Surveyor several years ago, I got to travel around the world to some of the hubs, and I know some of them are out there participating today. And that's a program where it takes the NASA satellite data and creates applications for developing countries to make decisions for land use, water use, and a lot of the comments I got as I was traveling around the world was, wow, NASA is so amazing because they give us all this data for free. And it's the data that y'all are going to be using on the Space Apps Challenge this weekend. And it's really cool that NASA, as a civil space program, and does provide all of our data, or most of our data, out there for everyone to use, so that you can go out there and get the data from Curiosity, from the rovers on Mars, and do a virtual reality where you can act like you're on the surface of Mars and even look under rocks and things like that. So it's just really incredible NASA does this for the world and has that data not only for weather, but for anybody to go out and use.
Okay, one more conspiracy question. Hashtag no filter. Why do you guys color edit or false color the images that you then share with the public?
Because black and white is boring.
Fair enough.
I disagree with that. It's not the only reason. So I actually have an image. I don't know if it's possible to show it, but it doesn't matter. So we often false color to get more information across. So you can black and white image. So photons aren't generally colored unless they're in the visible range. So an X-ray photon is not colorful in general, but it does have an energy associated with it. So depending on the information that you want, if it's intensity, you can color it to be able to make different features stand out so you can understand those features better. Or you can color code it by energy and get a good picture of what the different energy photons are coming from, which tells you something about how that object came to be. So there's information in false coloring. It's not all about just pretty pictures. And I think most of the time, most of the pictures that you see just have more information than you might expect. So I think the image that is showing right now is showing multiple wavelengths. So you have this composite image of all of these wavelengths together of the Crab Nebula. And at the bottom, you can see that each wavelength gives you a different piece of information. So if you're just looking at visible, you may see more just dust and gas. You won't see this highly energetic pulsar at the middle that's spinning, rapidly rotating, and these jets that are coming out. But if you look at the X-ray image, you can see much more structure at the center of all of that gas and dust. So we really try to get different information. The reason it's colored the way it is here is by energy. And so you get a complete picture of how that object was created and evolved and is evolving.
Not boring at all.
Not boring.
But it's not in black and white. Is it?
Where's Michelle? Let's go maybe toss some, there you go, questions to the audience.
I'm ready. Okay, so any questions for any of the panelists? Hands in the air. Anyone have a question? All right, towards the middle. We'll let the house lights come back on so we can see your faces. Here you go.
Got a question for Bill. Meteor data prediction for next year. Approximately how many wishes will be made upon shooting stars?
If you go outside during the Geminids and you can take the cold in a dark December night, you get about 100 per hour. How does that sound?
Sounds great. I do have a serious question too. Some meteor showers are year to year. They occur during the same time. Approximately how many will be different in 2019 than like 2018?
Only one, the Directorate meteor shower, which is October. I bet most of you have never heard of it. The Directorates are one of those all or nothing showers. They either, no one sees them, but in some years, like in 1933 and 1946, they put on these spectacular meteor storms. And next year, we're predicting an outburst of about 100 per hour. They'll be faint, but there'll be lots of them.
Questions?
So I had a question for Bill. Sorry, but I'm just curious. Speaking of the black hole and future space exploration to try to understand how the universe began, I'd be curious to hear what your theory is.
The universe began? Well, what is it called? In my day, it used to be the big, what's the inflationary hypothesis, whatever. Jessica's the person to do that. I just do rocks falling out of the sky, okay? So Jessica's the deep thinker up here. So it's the inflationary universe, but it's, you know, it's roughly the same, the Big Bang. It gets tweaked as time goes along and as new data come in from these wonderful satellites we put up there. Kobe and others are Cosmic Background Explorer, right? Yeah, see, I got it right. Yeah, the inflationary universe theory, which basically starts out with some form of explosion.
Jessica, did you want to chime in?
Was there, I didn't quite understand the question. Are you asking about black holes, or are you asking about?
I was just curious about what your individual theories are behind just sort of the evolution of things, whether it be from a black hole or the Big Bang, or if you had a different theory based on your knowledge.
Oh, and how the universe began.
Yes.
Right. So Big is still a fairly valid theory. The reason we study black holes, though, along with the first galaxies, is so we can understand how we get the universe that we see today. So if we look further back in time and we see the seeds of black holes forming in those very first galaxies, we can see if those black holes are being fed by the galaxies and growing, or if the black hole is creating or causing the galaxy to evolve in a particular way. So the reason we have all the different types of galaxies that we see today, we call it the galaxy zoo, we actually know how we've gotten there. And so one of the things that Lynx would do would look at those very first black hole seeds, those little black hole babies that are just now supermassive black holes that are growing and evolving and shaping our universe. So understanding that, along with what binds these together and binds our universe together, called the cosmic web, which is all this gas and dust in between, understanding that structure and how it evolves, are some of the most important questions that we have in understanding how our universe is why we see it today, the way we see it today. So we're kind of getting into the nitty-gritty. We want to understand the details, and that requires these massive, large telescopes.
Are there more questions? Sure.
And this is a question for just the panel. NASA does such wonderful, cool things. It's practical for like the people that are listening. What does it take to work at NASA? Like how, like your own kind of personal journeys to get where you are, and what advice would you give some of the people? I guess they're not here, but they're watching.
Come over here.
To work at NASA.
We've got a few.
I kind of gave my story. I came from a small town in Mississippi, and my dad was an engineer, so therefore that's what I knew. So I went in engineering, but didn't really learn about NASA until the Challenger accident. And I've had a really fun career as an engineer. I mean, I really get to go to work every day and play. And even as a manager, learning, making strategic decisions and technology how we're going to get to the moon and what type of structure are we going to create and take there, and how we're going to turn the urine back into drinking water and use the resources on the moon is really just incredible. So I've enjoyed thoroughly being an engineer, and would encourage others. But it's going to take really all professions. We're going to need architects, and one of the hardest problems about traveling in space now is the legal aspects. You can't mine something and bring it back to Earth. They're working on the legal aspects of how to do that type of stuff too. So my advice, the younger folks coming up, is to stay curious. I think Jessica said a lot of this earlier. Stay curious and get involved and follow your passions, and the things that you're doing today in the space apps, digging in and tackling challenging and learning how to solve problems. And it takes all types of diverse people to solve problems. Some of the best solutions for even our engineering problems come from non-engineers. We get good discussion from artists and everybody in every field that come up with ideas. Sometimes it's the people who aren't in the field best solution. And so stay curious and give your ideas. Be willing to speak up, to come to the table and give your ideas and take that risk. And you might fail, but you'll learn from it. And so that would be my advice.
Yep. So my story, I'm Huntsville, Alabama, but I'm originally from the Maryland area. So go Terps. So my story is, when I was 12, I did really well in school, and family, friends, and church, they had an extra ticket to go down to Florida and go to Disney World. So that was my prize for doing a year. And while we were down there, we took a break from the amusement parks and went to Kennedy Space Center. And my first question was, is there going to be a launch? And there's, of course, not that day. But I think they're in the middle of just processing the orbiters. But they showed a really cool video, and it was a real documentary of this space station on orbit. And they went and captured a comet to harvest the water, because they were running out of water on that space station. And I wanted to sign up and do that job. I was like, I want to go. When I talked to one of the museum curators there, there's like, well, we don't have, at the time, this is mid-90s, we didn't have a space station. We had Mir, but we didn't have 100 people on orbit, and we weren't capturing comets, unfortunately. But she told me, if this is something you want to do, then do well in science and math and engineering, and you could do this one day. That it was really the moment for me, and just put the goal that I wanted to work at NASA at that age, and just work to it. So I went to school, went for aerospace engineering and physics, started doing the practical part of doing internships. I also drove buses, which was asked during my job interview as a really cool thing, and I actually got to drive some space hardware from a shuttle mission back up here as part of my job. because of that experience. So don't count any extra experience you've had. But I came down to Marshall. I've been here for 10 years. I Materials and Processes Lab. I've worked on the Constellation program when we were building the Ares 1 rocket, and started working in the Advanced Concepts Office, so looking at missions far away, and then started working in the Space Systems Department, where my day goes from going in the lab, physically working on hardware, to organizing meetings and telecons and working on requirements and verifying those requirements. So it's a pretty busy day every day, but it's been a really cool journey. So
if you're interested in working at NASA and you're a U.S. citizen, there are job opportunities out there on usajobs.gov, and I know at Marshall Space Flight Center we have a couple coming out pretty soon for people just graduating in December in the electrical engineering and software engineering. And so if you keep up with the jobs at NASA, there's a lot of them out, not right now, but within the next year, where we are hiring and really need those young minds and new talents coming in to help us solve these problems.
I think solving problems is the most important thing, and expect the unexpected, all right? Because in my line of work, we don't have much meteoroid data from other places outside of Earth, right? And you know, there are days like a few years back, I was out at JPL and they were talking about the first interstellar mission, which is very cool and exciting, right? But it was like, kind of a think tank. And they turned to me and said, "What's the meteoroid environment like in Alpha Centauri?" And after I thought, are they out of their minds? I began, sketching out some limits on what we could put on the meteoroid environment in Alpha Centauri, even though I had absolutely no data. So being able to solve problems and dealing with the unexpected. When you explore space, you're dealing with environments that are totally different from what we're used to here on Earth. And things out there take on a much different importance than stuff down here. So that's problem solving, whatever your degree in, is the most important thing that you need to do. If you're used to following a recipe, you're not going to get very far in exploring space.
More questions?
All right. So this is probably either for Jessica or Bill. So if we were to visit this, basically the what is it? The nebula? Is that right? What's on the screen right now?
Oh, Crab?
Crab Nebula. Okay. Mm-hmm. And because it's fall, if we were to visit it, would we be disappointed?
You would be dead. No, I'm just kidding.
No disappointment.
No, there's a lot of radiation that comes out of these objects, so there's a lot to consider. But our atmosphere protects us from X-rays, for example, and that's a really good thing. We want to be protected from X-rays, and that's why we have to go into space to observe them. If you go there, what with your eye are the visible wavelengths. So you'll see gas and dust of all different colors in the visible wavelength, but you won't see the deadly radiation that's not in the visible wavelength. You also won't be able to see things like radio waves and ultraviolet, infrared, right? So that comes out in a different way. So by seeing, we see with sensors and we see with our eyes. So depending on what you mean by interesting and what we're seeing with, I would say no, you absolutely wouldn't be disappointed, but you also couldn't get very close.
All right, tough question to follow up, but is there anyone else who wants to ask a question of the panel? We might have time for one or two more. Here.
I have a fun question that each of you can answer, and that is, what is your favorite object in the universe and why?
Ooh, that was a good one.
I'll go first. Europa. I can't wait for us to go to Europa and get down into the ocean that's much like our ocean here. It's the saltwater ocean. Europa goes around Jupiter because of the tectonic plates, the amount of force from Jupiter, it makes the tectonic plates rub together and actually creates enough energy to make that ocean liquid. And so I'm hoping that we're going to go there and find microbial or even bigger life.
Next, the Earth. I mean, it's true. We have a pretty awesome planet, and we're looking for other exoplanets that are like the Earth. We have a lot to explore here, and there's a lot we can do here. So it's pretty awesome that we can explore the rest of the universe from this really awesome planet. So maybe that was an uninteresting answer. But that's what I would say, just because of what we can do.
I know mine is Enceladus. It's one of the moons of Saturn. It's a really tiny moon, and because of its orbit, it's able to shoot jets out of the surface, and it's really neat because those jets are actually feeding one of the rings in Saturn. And one of my first internship programs, we did a group project and we studied Enceladus and how to land on it, and that was really, I thought that was insanely interesting because you have to, how do you land on a super icy surface that you don't know much about, and all you know is that it's shooting jets of some type of liquid, which Cassini, before it was retired, found was liquid water. It was in there, and so I know there's a lot of bias towards Europa, but I think this little guy named Enceladus over in Saturn has a lot to offer as well, and has a lot of really cool activity going on at that moon.
Well, Jessica took mine, but my backup would be one of Saturn's moons, Dione, because I think being on that moon where gravity is very low, and it would be easy to hop about, but the view from that moon, looking up and seeing Saturn, this beautiful ring planet covering a lot of the sky, that would just be awe-inspiring. So if I had a place I would go in the solar system, probably Dione or one of Saturn's moons, and it's just for the view.
They found Vulcan, so that was in the news the other day.
That was Goblin,
yeah.
And it's way out there.
Yeah, it's far, but that, in the universe, that would be a pretty cool place to go.
It'd be cold.
Yeah.
Okay, I think we have time for one more question.
Well, I like to agree. Earth is pretty interesting. Considering Earth, how is biomimicry being integrated into the spaceship?
I didn't hear the question. What was it?
How is biomimicry to the spaceship?
Biomimicry.
Yes.
I know that NASA is studying biomimicry. I don't know how it's being used in the new SLS vehicle. I'm not an expert in that area. I don't know if y'all.
To be honest, that's the first time I heard biomimicry. What is that?
It's the study of biological beings like whales. They can study whales, and the skin on the whale is using a certain function, so it can you can mimic that and do different things in space. But I'm not sure how that's being used. Y'all know.
I don't know how it's used on SLS or if it's used on SLS, but I do know we have people who are looking at peristaltic motion. So earthworms, for example, kind of inch around and they push material around them. And we can use that to embed sensors, so little robotics that can embed sensors and things. And we've looked at it, I've looked at it for potentially drilling on the surface of say, Mars. If you want to be able to embed, sensors down, or if you want to get samples out there in hard-to-reach locations, that peristaltic motion is actually really potentially useful. I think we've also looked at, I was trying to think for imagery. different types of like flies or bugs, or just different ways to do optics. Yeah, different. So I guess I don't have any great examples other than the ones that I've worked on. But yeah, I mean, it's definitely something that we should exploit. Absolutely. Mm-hmm.
You stumped the NASA experts. Good for you. Earned an A+. So for us today, I would love to just give our wonderful moderator and panelists a round of applause, if we could, for all of their insights.